this is a handout that goes with that X-ray protection and the part 1 and 2 of those recordings. You've gotten this PowerPoint already. This is just a document where I went through and kind of explained a few more of those things in detail, and I referred to those in the video so you'll know where to kind of plug this information back in. But the International Commission on Regulatory Units, when they set up all those safety standards, one of the things that they established was a way to measure the radiation, because prior to that there wasn't really a way to measure the radiation. So on this sheet I've given you, there's a set of old terms that were the original terms. They did do some upgrading and kind of change the terminology a little bit, but both terms are still used pretty frequently and interchangeably, so you may run across both sets of terms. So I wanted to explain both of them, kind of how they go together. And I put the newer terms in blue, the older terms are in red, and then I've got the definition for what they are underneath. So hopefully that makes sense. But the terminology and the way you measure radiation, if you're trying to measure X-ray exposure in the air, so if you were monitoring the radiation in a room, or if you were talking about how much radiation leaked out of a unit or something like that, so you're measuring the amount of radiation present in the air, you would use either coulombs per kilogram or Roentgens. So Roentgen or coulombs per kilogram would be the terminology you would use if you were measuring exposure in the air. If you were talking about how much radiation a person or a certain tissue absorbed, so absorption by the tissues, you would refer to those as either gray or rad. And so you would have a measurement. You might say that 3 gray of radiation was absorbed by the person that was exposed. Okay, so the last set of terms measures the effect of the radiation. So when you're using these terms, you're talking about the damage. Okay, and those terms are sievert or rim. So if you think about it this way, you could talk about, there was a radiation leak. Say there was a nuclear power plant that had a radiation leak at one of their units. And so the amount of radiation that leaked out would be measured in either coulombs per kilogram or Roentgens. The amount of exposure that the person got and what was absorbed into their body would be measured in grays or rad. And then you would follow that up by talking about how much damage was done or what the effect of that radiation was, and that would be referred to in sieverts or rims. And so that's kind of how those terms all work together. So you might see them all in one big sentence. So you had X amount of coulombs per kilogram leaked out of the nuclear reactor. The crew that were working there absorbed X amount of gray, and before it was all done, there was so many sieverts of damage occurred. So that's how those terms work. The next term I want to teach or talk to you about is erythema and alopecia. Those are the two most common initial effects of an overexposure to radiation. Again, not going to be happening when you take dental x-rays, but with a larger dose of radiation. And you see these very commonly with patients who have radiation treatments for cancer. You'll see erythema, which means reddening, like of the skin or the affected area. And then alopecia means hair loss. And a good way to remember that is most people are familiar with the medication Propecia, which is a medication to help you regrow hair. And the reason they named it Propecia is because the medical term for losing your hair is alopecia. Let's slide you over to the other side here. Okay, so some other terminology that we want to talk about right now. These are some post-exposure considerations, and it's more about the terminology and just being familiar with this terminology. Latent period. We talked about a latent image when we talked about film, and if you'll remember, the latent image means that the film had been exposed, but it hadn't been processed, so the image wasn't visible yet. Latent period is the same basic concept. the person has been exposed, but the damage hasn't shown up yet. So the exposure's happened, but the damage hasn't fully shown itself yet. That's the latent period. It's almost like an incubation period if you were talking about an infection. The period of injury is just the time that the injury is there. So say a person is exposed to radiation, there's a latent period. The period of injury would be when the burns presented and they had the burns. And then recovery period, and I had to put in there if it's a non-lethal dose. That's not talking about dental x-rays. That is talking about large amounts of radiation. So the recovery period would be the healing period unless it was a lethal dose of radiation. Some of the long-term effects of radiation, increase in all types of cancer, embryological defects, and I want to skip down to the bottom and talk about genetic mutations. The difference between an embryological defect and a genetic mutation is that an embryological defect affects that embryo. So typically in that case, you had a woman who was pregnant who was exposed to radiation, and something happened, say they had an extra arm or something when that baby was born. That can also affect either the egg or the sperm that was used in the fertilization. So it doesn't necessarily mean that the person was pregnant. The egg may have been exposed, or the sperm. And so when the egg was fertilized, that damage was present, and then the baby was born with a third arm or a third eye or something like that. But that's an embryological defect. That offspring was affected, but it was just a formation defect. A genetic mutation means that either the egg or the sperm was hit with radiation and it changed the genetic blueprint. So when that egg is fertilized and the offspring is born, they have that mutation, but it's encoded in the blueprint of their DNA. So that's a genetic disorder that can be passed from that offspring to future generations. So a genetic mutation is typically considered more serious because it doesn't end with that one offspring like an embryological defect would. Genetic mutations can carry on for many generations. Okay, I'll go back up. Cataracts, that's the hardening of the lens of the eye, and also shortened lifespan. Again, I can't say this enough. This is not dental x-rays. Patients don't seem to understand the difference, and the reason I keep pointing out the difference is, yes, these are long-term effects of radiation, and some of the earlier exposures, like 1900, when they were taking radiographs, even dental radiographs, you did see some of these things because it was not filtered. There was no consistency. There was really long exposures. But now we have all the safety mechanisms in place, and this is why. This is why we talk about radiation protection and safety, is because it is radiation, and these are some of the long-term considerations that you have to keep in mind. I talked a little bit about this in the PowerPoints with the points of measurement, but you have entrance dose, which means the surface of the skin where the radiation entered the body. You have an exit dose, which is the opposite side where the radiation exited the body. And then you can also take a depth dose measurement where it's in the center. The next list is probably the most important thing on this page in particular, is your tissue sensitivity. With tissue sensitivity, I just went through and I made a list of the top 3 most sensitive and the bottom 3 least sensitive. So the number 1 most sensitive body tissue to radiation are your reproductive cells. Okay? The reproductive cells, meaning egg and sperm, or your ovaries and your testes, are very sensitive to radiation. The next one on the list is the lymphatic tissue, so lymph nodes, or lymph nodes, I'm sorry. Lymph nodes, any of that lymphatic tissue. And the third most sensitive is bone marrow. Bone marrow is the center of those larger long bones where red blood cells are made. And sometimes you'll see bone marrow referred to as hematopoietic. Heme meaning blood or red blood cells, poietic meaning create. So hematopoietic means the cells that create the red blood cells, and that's your bone marrow. On your least sensitive side, you've got the nervous tissue, skeletal muscle, and mature bone. Mature bone as opposed to young bone that may still be growing, like a small child that's still growing. This is talking about an older adult where the bones are no longer growing. The reason kind of behind that sensitivity is there's something called the law of B and T, and the law of B and T says that a tissue's sensitivity is directly proportional to its reproductive rate, meaning how quickly those cells reproduce, and it's indirectly related to how specialized the cells are. So if you look at that list, your reproductive tissue is not very specific. It's very generic because that's the blueprint of everything. And they reproduce very fast. So they get a double whammy on being very, very sensitive because they do reproduce very fast and they're not specialized. Okay? If you go over to the nervous tissue, the reason that nervous tissue is the least sensitive in the whole body is it typically tends to reproduce very, very slow, if at all. If you think about someone that has a traumatic brain injury or a spinal column injury, the reason that those are so devastating is because the body doesn't repair nervous tissue the same way. It doesn't reproduce itself. It doesn't heal the same way. So a lot of times when you have nerve damage, that nerve damage is permanent because the cells don't repair and replace themselves. Nervous tissue is also very specialized. You can't take like a nerve cell from your fingertip and put it in the brain and say, hey, your nervous tissue, you should work here too. The cells are very, very specific. So they don't reproduce very fast at all, and they're very highly specialized. So nervous tissue gets the double whammy of not being sensitive. The last thing on this page is LD5030. It's just an interesting radiation safety term. That stands for lethal dose of 50% of the population within 30 days. And they've actually done studies, and I don't want a lot of information about these studies. I've read enough. But they actually, everything has a number. They know what the radiation dose to kill 50% of a population of rabbits within 30 days. They know fruit flies. They know cockroaches. They know humans. They know every possible thing that you could come up with. Trees. They know everything. Everything has a number, and it's called the LD5030. And again, that's lethal dose of radiation to kill 50% of a population in 30 days. Okay, that is all for this section of the radiation safety.